All right, so yesterday we learned a lot of angle pair names in the relationship, and we have to be able to recognize them, if whether they give us the two angles or they might give us the name of the angles, and we have to find a pair in a picture. And so in this diagram, we have 11 angles, and we have to do part A, tell whether the angles are vertical angles, a linear pair, angles on a line, angles around a point, or neither. And then part B says state the relationship between the angles given. Like, do they add up to 90? Are they equal? Do they add up to 180? Do they add up to 360? Are usually the typical relationships. So in number 1, they're asking us for angle 1 and angle 2. So if we find angle 1 and we find angle 2, hopefully immediately you see that angle 1 and angle 2 are two angles on the straight line. They have a little separator in between them. However, if you take angle 1 and you take angle 2, see how they make that half circle? Well, anytime you got two angles next to each other on a line and they add up to, or they form that half circle, that means they're going to add up to equal 180 degrees. And they're a pair of angles because there's two of them, and they lie on a line. And so in this case, we can call them a linear pair. You can also call them angles on a line, but because there's two of them, that's why we can be a little bit more specific and call them a linear pair. And then they want to know the relationship between them. And so we're going to go ahead and say that angle 1 plus angle 2 equals 180 degrees. Okay. All right, we're going to go ahead and erase and reset our picture and go to the next pair. Next one says angle 7 and angle 9. So angle 7, angle 9. And as soon as I see those, I see these two lines that form 7 and 9. And angle 7's on one side, angle 9's on the other. And it looks like that little bow tie picture. And so I know that those are called vertical angles. Okay, maybe it'd be helpful if I drew a little picture over here. Just take it out of that complicated picture. Same thing with linear pair. Okay, so when you're looking for that shape, when you see a linear pair, that you're looking for that shape with vertical angles. And vertical angles have exactly the same measure. So we can go ahead and say that angle 7 is going to be congruent to angle 9. They'll have the same measure. All right, number 3. Angle 2 and angle 5. Angle 2 and angle 5. Angle 2 is here. Angle 5 is here. And it seems like we have that same kind of bow tie shape, except if you notice, if I trace over angle 2 sides, you're going to see that it's not exactly the same two sides as angle 5. See how this line here isn't traced over? So we have a problem there. 2 and 5 are very deceiving. They are almost vertical angles, but they are not. And so if we think of any of the other kinds, they're not vertical. They are not a linear pair because they're not next to each other on the line like 1 and 2 are. They are not angles on a line. They're not angles around a point. And so on this one, we're going to have to go with the neither. And because it's a neither, there's no relationship between their measures. We have no idea what their measures either add up to or whether they're equal or not. So we can't say anything there. Okay, number 4. We got angles 3, 4, and 5. So let's see, angle 3, angle 4, and angle 5. And as soon as I see that, everybody see this line here? Do you see that if I go from where angle 5 starts to where he ends, angle 4, and then angle 3, we get that half circle again. We cannot call these ones linear pair like 1 and 2 because pair refers to 2, and there's 3 of them. And we know that pair doesn't mean 3, pair means 2. So we're going to go ahead and call these angles on a line. Angles on a line. And what happens with these, because they make that half circle, they're going to add up to equal 180 degrees. So we can go ahead and say angle 3 plus angle 4 plus angle 5 is equal to 180 degrees. Okay, number 5. In number 5, they're saying angle 6 and angle 9. Angle 6 and angle 9. All right. Everybody see this line? Separator in between. If I go from angle 6 all the way to angle 9, there's that half circle again, and this time there are 2 of them, and so we can go ahead and call these a linear pair. And because they form that half circle, we know that they add up to equal 180, so we're going to say angle 6 plus angle 9 is equal to 180 degrees. Okay. Next one's up, angle 4 and angle 5. Angle 4 and angle 5. So angle 4 and angle 5 do not lie all on a straight line. They lie on something like that. So they're not vertical. Those aren't bow tie. Not a linear pair because they're not on a line. Angles on a line. No, angles around a point. Doesn't go all the way around. And so I'm going to have to go with neither. The only thing that you might be able to call them or could call them, which isn't a choice up there, but you can still use it, because they're sharing this vertex and the side between them, they are what they call adjacent. So I'm going to go ahead and say adjacent angles. However, adjacent angles, they don't have to add up to 90, 180. They don't have to be equal. And so I'm going to have to say that there's not really a relationship there with adjacent angles. And so maybe that's why adjacent wasn't a choice. Okay, next one. Angle 2 and angle 9. Angle 2 and angle 9. Oh, wow. Well, they are not even close to being by each other, right? So vertical, no. They would have to be sharing that vertex like a bow tie. Linear pair, no. Angles on a line, no. They're not on the same line. Angles around a point, no. I'm going to have to go with neither on this one, and they are not adjacent either. They're not even next to each other, so we'll say neither. And because they are neither, they're not going to have any sort of relationship here. Okay? All right, next one. We are looking at angle 6 and angle 8. Here's angle 6. Here is angle 8. Now those are closer to each other, and I'm going to go ahead and trace over the sides of angle 6. Okay. And so I'm tracing over the other side of angle 6. And does everybody see how those are 2 intersecting lines, and we have angle 6 on one side of this intersection point or vertex and angle 8 on the other? And that's that classic example of vertical angles. And so we're going to go ahead and call these vertical angles. And we can go ahead and say that angle 6 must be congruent to angle 8. Vertical angles are always congruent. And I kept on forgetting to draw my little picture. So again, there's that vertical angle picture. That's what you're looking for there that we have. Adjacent angles. I can go ahead and draw a pair of adjacent angles. They share this vertex and they share this side. Okay. Number 5 was linear pair, which looks like a line with a little divider separating into 2 angles. Angles on a line looks very similar, except it was 3 angles there. All right, so we're back on track. All right, let me erase, and let's go ahead and take a look at what they're giving us now. I don't know why I can't erase that. All right, well, I don't know. So we're going to keep going. Maybe we'll use a different color now that it won't let me erase that. We got angle 10 and angle 11. So here's angle 10 And here's angle 11, and there's the line that they both lie on with the separator in between us. If we go from where angle 10 starts to all the way to where angle 11, there's that half circle. And so those are two angles on a line, also known as a linear pair. And that half circle means that they add up to 180. So angle 10 plus angle 11 equals 180 degrees. Okay, let's go ahead and move up a little bit. Can't move up too far. I'm going to lose my picture. So number 10 says angle 1, angle 2, angle 3, angle 4, and angle 5. Holy cow. Okay. Oh, now it's letting me erase for some reason. That's good. Okay, so angle 1, angle 2, angle 3, angle 4, and angle 5. All right, so what you have to notice is if we start at angle 1 and we go to angle 2 and angle 3 and angle 4 and angle 5, you just made a circle. Those circles are 360 degrees, and those are all the angles around a point. And so that's what they call angles around a point. And we could go ahead and say that angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 equals 360 degrees every single time. Okay? A little picture of that would be literally what you see there. You got a bunch of angles all coming from the same point. Okay? I forgot the number 9, draw my linear pair again. Okay? All right, number 11. Number 11. Angle 6, 7, 8, and 9. So 6, 7, 8, and 9. Okay, so we have the same kind of situation that here's our point. If we start at 6, go to 7, 2, 8, and all the way to 9, there it is. This is the only difference is that this is only 4 angles that add up to 360 instead of number 10, 5 angles adding up to 360. But these are still angles around a point. And we can go ahead and say that angle 6 plus angle 7 plus angle 8 plus angle 9 equals 360 degrees. Okay, and again, same kind of picture as in number 10. The only difference is that this was only 4 angles. Number 12. We got angle 1 and angle 5. Angle 1 and angle 5. They are next to each other, so we can call them adjacent. However, nope. See, that's not a straight line. So that's not a linear pair. It's not angles on a line. It's not angles around the point. And they're not vertical. So the only thing we can call 1 and 5 are adjacent. They're next to each other. They share that vertex right here. And they share the side between them there. But that's all we can say about them. Adjacent angles don't have to do anything specific, like equal each other or add up to 180, add up to 90, add up to 360. They don't have to do anything like that. They're just next to each other. They can have the same measure. They could have different measures. We have no idea. Okay. And so that picture again, two adjacent angles are literally just two angles that are next to each other. Okay. Last one, we got angle 5 and angle 3. Angle 5 and angle 3. 5 is here. 3 is here. And they didn't say 4, right? Okay, so those are not vertical. That is not a bow tie. They are not a linear pair because they are not next to each other on a straight line. They kind of are on a straight line, but 4 is in there too, so that doesn't work. They're not angles all the way around point. And so this was a neither. And because it's a neither, those angles have zero relationships. They could be the same, they don't have to be the same. And so that one is done. Okay, let's move on and see what they have down here. In number 14, we have a little diagram. It says in the diagram below, DB, everybody see that symbol? Perpendicular. Great symbol because that's a long word to spell out if there wasn't a symbol for it. And hopefully you guys remember that that symbol is a great symbol. It tells you that there are right angles. Okay, so where DB meets BC, that is a 90-degree angle. And as soon as I see that, does everybody see how part of that 90-degree angle is 20? Well, if I take 90 degrees and I take away 20, I could go ahead and find the other angle that they're probably going to ask me to find is 70. Okay. We are also given another pair of perpendiculars, and this time it's EB is perpendicular to BF. And so this is also a 90-degree angle. And do you guys see how the 70 we just found is part of that 90-degree angle? So if we take 90 degrees and we take away the 70, there'll be, guess what, 20 left for this angle here. Okay. So in part A, it says find the measures of angle EBD. So angle EBD. If I find angle E to B to D, that's that 20-degree angle that we just found. Okay. They also want us to find angle DBF. DBF. So if I trace over D to B to F, that's that 70-degree angle that we found. Okay. And angle ABE. Oh, we don't have that one yet. However, if we realize that angle ABE is the only angle that we don't have, okay, remember that this is a straight angle and that all of these angles are next to each other and have to add up to 180. So if we take 180 degrees and take away the 20, the 70, and the other 20, we'll be left with what that question mark equals. And if you do the math, you're going to find that it comes out to be 70. Another way to do it is that this has to be a 90-degree angle as well. And if part of it is that 20, the other part has to be that 70. And so now we found angle ABE as 70. Okay, done with part A. Part B, what could angle EBD? I'm going to go ahead and change colors so I can see this a little bit better. Okay, angle EBD. EBD is right here. That's the 20. And angle DBF. DBF is this one here, which is the 70. Well, since 20 plus 70 is equal to 90 degrees, we could call them complementary. We could also call them adjacent since they're next to each other. And I think that's all the words that we could possibly use for that. All right, number 15. Two supplementary, remember supplementary? Is 180 degrees. Have the measures in the ratio of 5 to 4. Hopefully you remember that all you have to do is attach an x to them. You got a 5x and a 4x. What is the measure of the larger angle? So the easiest way to think about supplementary angles is like a linear pair where one angle is 5x and the other one is 4x. And so all we have to do is take 5x, add 4x, set it equal to 180 degrees. That's 9x. Equal to 180. When I divide by 9, x will come out to equal 20. Did we answer the question though? No. They want to know the larger angle. The larger angle is going to be the 5x. And so 5 times 20 is equal to 100 degrees. If you want to double check it, you could always plug in here. 4 times 20 is 80. This one we said is 100. 100 plus 80 adds up to 180. And two angles that add up to 180 are called supplementary. So that one is finished. Okay, I'll see you guys on the back side in the next video.